If not, I'll just move on to the next one. Okay. Okay, yeah. First, some of you said you had solutions for the 8 queens problem. Let's discuss that. Does anyone wanna unmute and tell me that solution? Someone sent a message in chat saying you'd solved it, right?
Sir, can I see?
Yeah.
So first queen will be at B1.
Okay.
B1.
Oh, sorry, B1.
And then second queen will be at A5. A5 here.
Okay.
Third will be at C8.
A,
And fourth will be at D4.
B4.
5 2, and then 6 6 6 F6.
Can't be at F6, right? Because these two queens attack each other.
We can put at F7.
Okay.
Then 7 G3, and H6.
Yeah, this seems fine to me. Yeah, this is a valid solution.
Sir, can you tell one more?
Yeah, sure.
Yes, sir. I have another one as well. So queen on B1.
Yeah. Queen on B1.
Queen on D2.
D2.
Queen on G3.
D3.
Oh, sorry, F3. Queen on H4.
Okay.
Queen on G7. Queen on E8. Queen on C5. Queen on A6.
Yeah.
Sir, can I tell you my other arrangement?
Yeah. We'll see one more arrangement and then I'll.
Sir,
Yeah.
Sir, can I tell?
Sir,
Can I tell?
One second. Someone else is telling me. Yeah. C.
C1.
C1.
Queen on C1. Then a queen on B3.
B3 or D3?
B3. B for
B3.
balloon. Then A5.
5.
Then E2.
E2.
Then not A8. F8.
F8.
D7.
D7.
G6. And H4.
Sir, can I tell my solution?
So may I tell mine?
Sir, may I tell my
Can I tell the last
Okay,
one I
okay,
asked
okay.
last session to sir?
answer, sir?
I did it.
Can I tell one, sir?
One second.
Sir, can I tell? Sir, can I tell?
One second. Wait. The thing is, I want to discuss. Like, there's a lot of solutions, right? And all of you have. I'm sure you have unique solutions, but the thing is, I want to discuss how many total possible solutions there are. So I will just I'll give you like a thing of all the possible template solutions basically, and then we'll basically see like which of these solutions each of you got. Is that okay? Like I have a slide with like all the possible solutions, and then we'll like count the symmetries, and then we'll see like how many like which of the solutions each of you got, and you can just like let me know or like send it in the chat or whatever. Okay. 1 second. Okay. So this is okay. Let's go back to this one. Okay. How many, so like given one solution, right? How many other solutions can I get from it?
So can I say?
Yeah.
So actually, this is already very known fact that answer is totally 92 possible solutions. But I don't know
Okay.
the reason why, but I've come across this in some websites. Same here, sir.
Okay. Yeah, like in total it's 92, yes. My question is like specifically now that I know this is one valid solution, right?
Yes, sir.
How many other solutions can I get from this particular solution? Not like solutions in total, just like solutions from this by like rotating it or whatever.
Sir,
Yeah.
sir, I figured if you rotate like
So we
in
can get
each
four.
column and each row, there's one queen. Exactly
Yes.
one queen. So if we
Hmm.
rotate each or the rows or rotate the columns, we'll be getting a solution.
So we'll get a new solution, right? And we can
But
rotate it how many times?
uh, like
So 4 times.
9 factorial.
Uh, sorry, where did 9 factorial come from? I lost you.
Because the each row can be rotated, each column can be rotated, and each row can also be
Uh,
rotated.
okay. When
But
I
but
say, yeah,
but
sorry.
there's
Go
also
ahead.
one more thing I haven't considered here, the diagonals. I've only considered the
Yeah,
rows, and there should be only one queen in every diagonal too.
yeah, exactly. So, like for example, here, so 1 second, let me just clarify something. When I said rotate, I meant like rotate the entire chessboard, not like permute or like swap out two of the rows. Because, for example, here, if you swap row 7 and row 8, right? Then this
Yeah,
queen comes here and then like
yeah,
they're
they
on the same diagonal. Yeah. Yeah. So that's the thing. Also, uh, yeah.
So actually, once we place a type of 8 queens, sir, and which don't attack each other, they can be tilted in 4 ways. And so in total, there are 23 primary solution, and they are just rotated and made like other solutions.
So you're saying each thing can be rotated 4 ways, so there's probably like 23 unique solutions, and then by rotations we get 4 more.
No, so by rotation, we get 3
No,
more.
sorry.
In total, there
Yeah.
are 4.
So in total there are 4, so 23 times 4 is 92 is what you're saying.
Yeah,
sir.
yes, sir.
Sir,
Okay.
how could you know there are 23 total?
Because he already knows there's 92 total, he's dividing it by 4 and saying there's probably 23. We'll see if he's right.
Um, and
Okay.
one more thing I just noticed, if you rotate the rows like that, you won't be getting a kind of a new solution. But suppose you move column H to the left of column A, that
Hmm.
means you'll still be getting a new solution.
Yes.
And you can move G and H to the left of A, you'll be getting a new solution. And you'll move F, G,
Hmm.
H to, so we can do that.
You can do that, but there's not always a guarantee you'll get a new solution. Sometimes you might not get a solution. We'll see an example of that. Also, 1 second, before that, someone said there needs to be a queen on every diagonal, if I'm not wrong. right?
So I don't think I did that.
Yeah, like I just want to point out there doesn't need to be a queen on every diagonal. Like for example, this diagonal, there's no queen on it. Okay.
Yeah. So like the solution I made, I didn't have a
Hmm.
queen on a like 6. I didn't
Yeah,
have
like
one.
okay, sure. Um, okay. In case like people didn't understand what they said right now, basically we can like move everything to the left one and see if we're able to find a new solution. So something like doing this and then seeing if we can like get new solutions. Like for example, this generates a new solution that's not like a mirror image or like symmetrical to what we had before, right? Like you can't rotate the previous one and get this or something. Does that make sense? That's okay, right?
Yes, sir.
And then like basically you can do it one more time and get another solution. Um, here's the thing,
I
you
have
can't
one
do
way
it for
for
a third
solution.
time. One second, let me just explain why you can't just keep doing this process and then you can this thing, like whatever you want to say, you can say. So when you do it for the third time, right, what ends up happening is uh, this queen is now attacked by this queen. So you can't actually keep doing this process over and over again. And like once you do it 8 times, it just cycles back to the original position, right? So like it's a good method to like try to get some more. But actually, if you think about it, like you still won't get like a lot more solutions. Like for example, now no matter how many times you shift it, these two will be attacking each other until you shift it like 3 more times, right? And then we'll have to check if there's anything else attacking. Yeah, sorry. What did you want to say?
I have sent you my answer on the chat.
Answer to what? Like a solution for the problem.
Sir, can I tell my solution, sir?
Uh, 1 second. We're discussing the symmetries of the solution.
Okay,
Like
sir.
I said last session, send your like I'll add a part of the assignment where you can just submit solutions to me and I'll go through all of them. Okay?
Okay, sir.
Yeah. Thank
I
you.
sent it, sir.
Okay. Yeah. So here's the thing. Do all of us agree that?
I sent in
Sorry,
the
I
chat,
missed
sir.
something now.
I sent the solution for this in the chat, sir.
Okay.
Sir, I also my.
Yeah, I'll go through all of them later. Okay. Like I'll have a recording meeting. I'll go through everything. Uh, yeah. So here's the thing. Do we all agree that like we have 4 rotations available? So like there's at least 4 symmetries per queen on the board. Like not for queen on the board, for each solution of the problem. What about if I take the mirror image of this? Will that give me a new solution or one of the old solutions?
So I think it would give you one of the old solutions.
Sir, how to send? Sir, how do I send, sir? Sir,
Okay. Sending your solutions, you can submit it as an assignment later. Let's not focus on that right now, okay?
no, sir. How do I send it?
What do you mean? How do you send it?
Like
So
a different website. How
I'll
do I
give
send?
all the instructions in the assignment.
Okay, so there will be an assignment in the Google Classroom.
Yeah.
You can upload it there. There is no requirement for you to send it on the chat on the meeting. Thank you.
Thank you. Focus on like what I'm trying to explain right now. We can discuss the solutions later. Okay. Yeah. So yeah, someone had something to say about the mirror images, right?
Yes, sir.
Yeah. Go ahead.
Sir, at first I thought it would be one of the old solutions, but now I think it's like a new one.
It will be like a new solution, right?
Yeah.
But
Sir,
it's also a solution. Yeah.
can I say my solution?
All the solutions will be in the assignment later in the Google Class.
Okay, sir.
Sir,
Okay.
there are 92 solutions.
Yes. Yeah. So
Sir,
you take the yeah.
sir, is it actually true that there are like 92 solutions for this?
Yes, and I'll be showing you all 92 solutions. Okay. So you take the mirror image of this, and then you can rotate the mirror image another 4 times, right?
Yes, sir.
So in total, from any one solution, you can get 8 more solutions, right? Is that okay?
Yeah.
Because like you have like the 3 rotations, so you have 4 with the original thing, and then after mirror image, you have 3 more rotations, so you have 8 total. Okay. Uh,
Sir,
here's where it
what about moving one left and one right, sir? We need to count that also for getting it, sir. Like we get three solutions by doing that.
moving one left and one right, I'm going to count as a new solution on its own completely.
Yes, sir. Then we're getting in left side we're getting 12 and right side we're getting 12, right, sir. Once we move one square, we can again rotate the chessboard to get another 4 solutions.
Yeah, but that will be counted as a completely different solution. Here I'm just seeing solutions that are symmetrical to the original one.
Okay, sir.
Also, like, what's it called? Like, for example, you have to do this really carefully. Even like last time I did this, it wasn't a valid solution and I didn't notice it. Like, for example, these two are looking at each other,
Yes, sir.
right? So like you can't do it just automatically. You have to do it like really carefully. It's very rare that you can actually get a solution like this. Okay.
Okay, sir.
Yeah. So what was I saying? Yeah. So from each solution you'll get 8 more. Is that okay for everyone? Now I'll show you.
Sir,
So now we had 92 solutions total, right? But then 92 is not divisible by 8. Right. 92 by 8 is 11 and a half. So I'm going to show you like 12 different solutions now. These are the 12 solutions I have. Here's the thing. Here's the thing. Only 11 of these solutions will have 8 symmetries, and one of the solution will not have 8 symmetries. Can anyone tell me which one that is?
sir, other than these 12 solutions, I have a different one.
So can you repeat the question? I didn't hear.
So we saw that to whoever said you have a different one second, I'll come back to you. Here's the thing. We have 8 symmetries for each solution, right? You understood where this comes from?
Where exactly does the 8 come from?
So given any solution, I can rotate it to get 4 more. Like 3 more solutions for 4 in total. And I can also just flip it, right? And then I can rotate it again. So it's 8 solutions in total. Is that okay?
Sir, do we get 4
rotated and what else? There's only 2 flips, right? And there are 4 rotates.
No, I can rotate it after I flip it, right? So that will give me 4 more solutions, right?
Yeah, I got it.
Yeah.
Sir,
So
Sir, is it the 12th solution that has four symmetries, sir?
It has to be
okay.
symmetrical.
So why does the 12th one only have 4?
Sir, because like when we are rotating or taking a mirror, it might actually have like same of might have an old solution.
Yeah. So this one already has a rotational symmetry of 180 degrees, right?
Sir, it has.
Yeah, so when you flip
yeah,
it, it represents the
yeah,
same solution.
Yes, sir.
So what
yeah,
happens is like after 180 degrees, this goes here, this goes here, this goes here, this goes here, and this goes here, right?
yeah.
Yes, sir.
So yeah, basically because this one already has a rotational symmetry, you can only rotate it 2 times. Because after you rotate it 2 times, what happens is you just go back to the original state. Same way after flipping, it will still be have rotational symmetry, so you can only rotate it 1 more time, and the second time it will go back to the original state. So you have 4 states for this, not 8. Okay. So what you actually have is 11 times 8 plus 4, which is 92.
Sir,
Yeah.
sir, my solution is not in any of these. I can't find it.
Have you tried taking the mirror image and rotating all of them?
Yeah, I think so. I can't like find one like that
Okay.
seems to match
If you
I
mine.
think
found
your
mine.
solutions aren't in any of these, like again, submit it in the assignment. I'll tell you which of them they are and how to get to them. Okay?
Okay.
Yeah.
So can
Like
you
have you
explain?
already posted the assignment or
No,
something?
I have not. I have not.
Okay.
It'll be tonight after the session.
Okay.
Okay.
So can you explain again how you got 92?
Yes. So for each solution, right? Did you understand how I got the 8 number?
Yes, sir.
So each solution I can do it 8 times, right? So and I have 11 of them here. Exclude solution 12 for now. From these 11 solutions, I get 88 solutions, right?
Yes.
Solution 12, I can't rotate it 4 times because if it has a rotational symmetry, right?
Yeah.
So what happens is if I rotate it 2 times, we get our original position back, right? Is that okay?
Okay, sir.
But what if we flip it instead of
And then you flip
turning
it,
it around?
and then you can rotate it 2 more times. That's where you get like the total of 4 from. Is that okay?
Yeah.
Yeah, thanks. Okay. So that's how we get 92. Is there something else you noticed that's special about 12? If you notice, it's the only one that doesn't have any queens on its diagonals, right? Uh,
Yeah.
no, actually, this one doesn't either. But like not having a queen on its diagonal is like a compulsory scenario for having rotational symmetry of 180 degrees. What I mean is, if there had been a queen here or something, right? Uh, every time I rotate, you would have gone here, and then here, and then here. So like every time we just get like a new position, right?
Yes, sir.
Does that make sense? So like the fact that a queen isn't on the diagonal is what like helps us do rotational symmetry. Because otherwise we'd need like a queen here and a queen here, which is not possible, or a queen here and a queen here, which is not possible. Yeah.
And the 4 comes from the 12th solution, is it?
Yes. So like 88 comes from the first 11 solutions and then 4 from the 12th one for 92 total.
Got it. Thank you.
Okay. Yeah. Uh, Okay, so does anyone have any doubts about the 8 queens problem? Like if you have more solutions, you can submit them in the assignment. If you think they're not in this, I will tell you whether or not they're in this. But does anyone have any doubts as to how we got 92?
No, sir.
Okay.
I do. I couldn't
Uh,
understand how there are 90.
okay. Do you understand how there are 8 solutions?
Not really, sir. It all went over my head.
Okay, sure. Let's start with a smaller case. Let's start with 4 solutions. So imagine we're doing a 4x4 board, right?
Yes.
Actually, no, 4x4, they're all. Hmm. Okay, like it's fine. Let's imagine we're doing it in a 4x4 board. Okay. So here's the thing. Uh, if I here there's no rotations because they're already like have rotational symmetry. But if I flip this, right? That's a nine. Yeah. So can I move all of them this way so that like there's another solution? And this is different
Yes.
from the previous one, right?
Yes, we can rotate it.
This is the same as taking a mirror image, right? Because
Yes.
like this was my original solution. And if I had taken a mirror image across this, I get this.
Mm.
Right. Okay, but here's the thing. 4x4 already has like a rotational symmetry of 90 degrees. So I can't show rotational symmetry using this one. I will show rotational symmetry using this one instead. Yeah. So I'm going to rotate this whole thing by 90 degrees. Okay. I will, yeah. So what will end up happening is, I'll just mark it out so I don't make out this thing.
Sir, the queen on D7 will go to G4, sir.
Yeah, no. I misclicked. Yeah, okay. So, no, this will actually go here. Okay, yeah, okay, I got it. So this will go here, here, and here. This will go. Um, one second.
Sir, that will go to B A3, sir. A3. A3.
Uh,
F.
and I'm rotating this way, not this way. One second. This would go here. This would go here. This goes here. This goes here, and this goes here. Right? Yeah. Does that look okay? So by rotating this, I've gotten a new solution, right? Is that okay? Do you understand how this is a new solution?
Yes.
So basically, both by flipping it, I can get new solutions, or by rotating them, I can get new solutions, right?
Mm.
And like this is like a unique case where it's symmetrical, but in general, when I rotate them, I'll get 4 different rotations I can do before I go back to my original thing. Does that make sense?
Sir,
Go again.
sir,
Yeah.
you said you have 8 rotations for every solution that's put up
Yes.
here. So like in the solution you showed us you know the one you showed us before, like someone suggested.
Yes.
So we kind of rotated that, right? but some of them didn't turn out to be a solution where the queens attacked each other a little. So how do you know we have already avoided that?
Which rotation did the queens attack each other in?
Like you did F G H, like that thing.
This one? Like when I was
No,
rotating this one?
no, that not that one. Like I just realized now. Like it was sometime before.
Oh, like the one where I moved this here.
Which
Like I
one?
moved everything to the right one. You mean that?
Yeah.
That is just like an idea they gave. That's not something I said. They said like that could be a nice way to try and find more solutions. So I tried it, but then we saw that like it doesn't really work most of the time, right?
So then how do you get 8 then?
My 8 are from rotating the board completely, right?
Uh,
Like how I just did one rotation, like that I can do 4 rotations if it's not symmetric. And the other thing I can do is I can flip it and then rotate it 4 times, right?
yeah. So you get
So
8.
that's where my 8 solutions come from. Is that okay?
Yes, sir.
Yeah. So that my 8 solutions come from there. And however, this last one, as we have seen, is symmetric, right? So like if I were to go back and flip that, I'd just get this original question back. Not flip it, like to rotate it. Right? Is that okay? So this one will only have 4 positions. So what ends up happening is these will give you 88 solutions, and then the last one will give you 4 solutions to give you a total of 92 solutions. Is that okay? Whoever said you hadn't understood. Okay. So I'm just gonna I'm going to assume that you understood. Okay. So here's the thing, right? We're not only interested in doing this for like an 8x8 chessboard. Sometimes we want to leave, like we want to think about this for like any number of queens or like an n×n chessboard with like n queens or whatever. So that's another interesting thing that we can think about, where like obviously like if the board is just one square, you put the queen there, that's your solution, and like you can't have any other solutions. If you have a 2x2 or a 3x3 board, there are no solutions. Okay. Yeah. So 2x2 or a 3x3 board, there are no solutions. Similarly, 4x4 board is the 2 solutions that I showed you. Like these are the only 2 valid solutions for a 4x4 board. And yeah, but then as you see, like when you go to 6 again, it gets smaller. But then after that, it starts increasing like exponentially, right? Like we had only like 92 or 12 solutions for 8. But then like by the time you get to 12, it's 14,000 and 1,700 like unique solutions. And actually, if you see, so we don't actually have a formula to calculate this. Not one that's been discovered yet. We only know like all these numbers because like we've brute forced them using computers, and like we checked every single possible scenario and we've counted all the valid ones. Okay, so we don't actually know what happens at like the level n. What we have done is we've calculated it. This is just Wikipedia. We've calculated it up to 27 queens on a 27x27 chessboard, and like the answer is like uh, 234 quadrillion unique solutions, total solutions, if I'm not wrong. Yeah, 234 quadrillion solutions.
Sir,
Yeah.
Sir, but with one queen, there should be infinity solutions, no?
With one queen?
With one queen, there should be infinity solutions, no?
Like you mean this case?
Yes.
How would there be infinite solutions?
Sir, because with one queen, we can place it anywhere.
But it's only a 1x1 chessboard, right?
Oh.
And even
Also, yeah, even if it was like an n×n chessboard, it would be like n square solutions total.
Okay, sir.
Yeah. So basically, like no one in the world knows what happens beyond 27. Like we have programs that can run it, but the thing is like we don't have a computer that can compute greater than 234 quadrillion calculations and then like let us know what happens after, right? So that's one interesting thing about this problem where like there is no formula yet. You can try to come up with something if you can. Like the Wikipedia article has all the numbers, see if you can like find anything. But yeah. What? Yeah. So that was it on the 8 queens problem. I have another problem I have. So okay, I wrote the solution here. Uh, can you find me a uh, arrangement of queens such that every single square in the chessboard is attacked? These queens can also attack themselves. It's allowed this time. And like, yeah, I mean, I wrote that the answer is 5 queens, but like, uh, can you find one for me?
So can we do this problem now?
Yeah.
Okay.
Sir, what's a domination problem?
Basically something like this where like we want to cover every single square or like every single option or possibility.
Sir, I can't hear your voice properly.
So it's basically like, is this better?
Yes, sir, yes.
Yeah. So it's basically like this kind of problem where you want to like cover every single square or cover like every single possibility for like some scenario.
Okay, sir. Thank you, sir.
Yeah. Like just off the top of my head, something similar would be like how many two-digit numbers do you need to choose such that like their prime factorization covers all the primes up to 20 or
Sir,
50 or
can
whatever.
you show a chessboard?
Yeah, sure.
Thank you.
Sir,
Yeah,
so the queens can attack each other, right?
yes. There's no
Okay.
condition saying they can't.
Sir, can two queens be in a same line, column,
Yeah, yeah.
like diagonal?
Yes, they can attack each other this time. There's no condition like last time.
Oh, okay, sir.
Sir, I noticed in my solution to the 8 queens problem, I noticed that all the squares except the ones with the queens were being attacked. Like, if you kept a queen there, it was being dominated. Like.
Yes. So like that's one solution we do have with like 8 queens, right? Can we try to find a solution with lesser than 8 queens?
But says at least 8 queens are required to occupy all squares.
Um, Try to do it with lesser than 8 queens.
Sir, I sent a message in the chat. It has less than 8 queens.
Okay, you've sent one with 6. That's nice. Yeah, that's a valid. Yeah, that looks right. So that's one with. So they've sent one with 6 queens. Can anyone try to find one with less than 6 queens?
Sir, I also
People
sent
who
the
have your
answer in
hands
chat.
raised, you can just unmute and speak.
Sir, I sent my
Yeah.
answer in chat.
Sir, in the solution given in the chat, I don't think so. G3 is attacked by any queen.
Yeah, G3 is not attacked. Yeah, thank you for pointing that out. Yeah, so yeah, and if that's not a valid solution, sorry.
So you could rather move the queen to G1 in his solution.
But then you have to check if.
Then C7
But
is
then
also not
C6.
attacking, sir.
But then
Sorry,
C6.
C6.
Yeah, C6. No, the F6
Sir,
queen
I found
attacks
one.
it. So if you move it to G1, that is a valid solution, I think. Yeah. I mean, yeah, like this does have 6 queens, but like let's try to find 6 queens, and then we do it with 5 and so on. Someone
Sir,
said they
I
found
found
one.
it with 5 queens. I'll send in chat.
Okay, sure. D5, D5. On B5, E5, and E4, A3, and C1. Uh, yeah, that seems to be right. Yeah, that's fine. So
Sir, even I sent the answer.
Sir, I sent my answer, but it has 6 queens.
Yeah, that's fine. We can try to do it with 6, and then like we can try to see if we can find one with 5.
The my
Yes,
answer is
Okay.
5.
I'm trying 5
Yeah.
queens, but I don't seem to get it.
Sure. Yeah, that's fine. Okay. So like this was like the one of the solutions I got for 5 queens. Sorry. Yeah. So basically, like all of these diagonals we know are covered by these, right? And these columns are also covered. Yeah. This we don't even need to do. But these columns are also covered, and oh no, this one's not valid. Something like this square isn't attacked, right? This square is not attacked by any of these queens. Yeah. Okay. So I'll just give you guys like one of the. Is this a valid solution?
Sir, answer is 5.
Yeah, it's 5. Do you have like a different 5 from the one I've written? Like one I've shown on the board?
Sir, I have a different 5. Can I
Okay,
say?
tell me. Yeah.
The positions are B3,
D3,
then E2,
E2,
then D4, then
yeah,
F5,
F5,
and C6.
C6. Oh, C6, sorry. Yeah. Um, yeah, that looks like it's right.
Sir, I have sent my solution to you, but it has 7 queens.
That's fine. Like we can start with more queens and then slowly we can like try to see if you can remove one and slightly like reorder the rest so that like it covers up for it and so on. That's how like we get the other solutions.
Okay, sir.
Yeah.
Sir, I have sent my solution, but it
Like
has 6
all
queens.
of us can just like we can try to start with like our original 8 queen solutions, try to remove one of them and then see if you can still cover it and keep removing one by one by one. That's fine.
Sir, I have sent my solution, but it is 6 queens.
Yeah, nice, that's good. Now try to see
Sir,
if you
I
can
sent
remove any of the.
Sir, I
Yeah.
sent
the
it with
photo
the
in the
arrow symbol.
chat.
Okay, yeah.
Sir,
So now,
I have sent
yeah,
it, but
okay.
it's 6 queens, sir.
Yeah, that's fine. If it's fine, if it's 6 or 7 queens also, we can like slowly try to like tweak things and then see if we can like eliminate one of them and get it right.
Can I
Yeah,
say my answer?
Sir, I got with
sure.
5 queens.
I'll see like one more 5 queens answer and then I'll move on to the next one.
Sir, I have got one. Can I say it, sir, Abhinav?
Okay.
Okay, sir. So in that figure,
Hmm.
we are taking B2,
B2,
C3,
C3,
D4,
D4.
and the last one H8. Yes, sir, this one.
Yeah. This is again just like a rotation of this one that I'd given, right?
Sir, I too found out the same, sir. Like
Hmm.
you can have 8 and then you can be keep on removing these and you can
Yeah.
dominate everything, sir.
Yes, sir. And this is the one which I also found.
Yeah. Another like interesting one is instead of the diagonal, you can place them like just above the diagonal in this scenario, and this will also cover all 64 square.
Sir, then can you also place it below the diagonal, sir?
I mean, yeah, it's symmetric, right? So it'll just be this. This is also a valid solution.
Sir, how many arrangements are there?
This one I'm not sure. I think there should be like
Sir, I sent it in the.
around 5. So,
Sir, I sent it in the
uh,
chat for 5 queens.
yeah, I think there's around 5,000 solutions like this, if I'm not wrong, if I remember correctly. Like for solutions like this, if I'm not wrong, the number was like 4,860 or something like that. Yeah, the number is 4,860. Yeah. Counting these, like there's a lot more solutions here, and then we'll have to do the same, check if it's symmetric, and then flip it and do that and do this. But there's a lot more solutions to this than the 8 queens problem. Like even now we've already like gotten 4 different unique solutions, right?
Sir, I have got one five with 5 queens, sir. I got one solution.
Nice, good job. Yeah, okay. Next, what did I want to do? I wanted to yeah, okay. So this was like the last puzzle I had. Basically, if you remember our old night store,
Sir, Rook store is very easy, sir. Sir, Rook store is very easy, sir.
Yeah, sir.
yes,
Bookstore.
Go
but
vertically
It is
to
very
the
easy.
one second. Let me finish the question. I know we can just like cover everything because it's horizontal and vertical. My question for you guys is, how many moves can I cover the whole board in?
Sir,
Can I say
Yeah.
some?
sir, I have a doubt. In the in
Uh-huh.
this rook store, if you pass by a square, but it's in the middle of the move. Does it count that? Does
It
it
counts it as
be
visited.
counted?
Yes.
Okay. So I think we can solve it.
Yeah, so solve it and like try like one of you tell me like how many moves you think it will take.
Sir, 15 moves.
Sir, can I say, sir?
Sir, 15 moves.
15 moves.
Sir,
Okay.
Can I
I
say,
I
Abhinav?
arranged it in the chess, so I'm just going to send it.
Okay.
Sir, A1 to A8, then to B8, then to B1, then to C8, C1, then to C8, like that, sir. Just keep going.
Basically this, right?
Sir,
You start here and
A1
you
Sir, go to
Sir, A1 to A8, then
A8
B8.
and just continue like that. You'll do it and do it in 15 moves.
yeah. And you can also extend this to any n cross n board, and how many moves will it take then?
And maximum it can take 63 moves.
Sir, I found a way where you can return to those places.
Sir, for any n cross n board, the number of moves for the number of minimum moves for the rook's tour would be n plus n minus 1.
Yes, which is 2n minus 1, right?
Sir,
Yeah.
sir, I found a way. You can use 16 moves, but you can traverse the whole board and then return back
Come
to your
back to
same
our
point.
starting point. Okay, how will you
You
do
can
that?
return back to the
So
same point.
first, you have to start
First,
from
you have to take
A1,
rook to H1.
then to A8, and then to
H1.
H8, H7,
Okay.
and then to B7, and then keep going like that in a zigzag manner.
Yeah,
And then you return back to your knight.
perfect.
It will take.
It forms like a double E kind of thing.
Mm-hmm. Another option we had was like in
A1
our
to
old solution
A8
itself,
like that.
we
And
can
then
just
after
not
we
visit the
should not
last
go to
row.
the last row.
Yeah, and then we can just do this, and then it's pretty much the exact same solution you just said, but like
So,
rotated. If you
but
go to,
either way, you would
it's
require
the same
at least
solution.
16 solutions.
So for this you'll need 2n moves, and if you don't want to come back to the starting point, you'll need 2n minus 1 moves, right?
Sir, we can also do
Sir,
first.
you can also
First,
go in a
one
spiral
row
manner.
fully. Sir, one row fully, then 2 row, then 3 row.
Yeah.
Sir, I did it in 15 moves.
Yes. Good job.
Sir,
Can I get
Okay.
answer?
Is it different to one of these?
Yes, sir.
Okay. Tell me.
A8,
Okay.
H8,
Hmm.
H1,
Hmm.
B1,
Hmm.
B7. Like that you go on till the middle square.
Good
15
job.
moves, sir.
Yeah. Okay. So that was just like a simple this thing. So now I had one last thing I had left I wanted to discuss with you guys. Does everyone remember the formula? It was Abhinav, right? Who gave the night stool problem?
Yes, sir.
Yeah. Can someone repeat the formula for me?
So I'll itself repeat it, sir.
Okay.
If n is greater than 3,
Hmm. 1 second. Let
N
me
is
open a
great.
whiteboard. Yeah, you can repeat
Is
it.
it
Like
already
I'll just
found?
write it down.
okay, sir. If n
Hmm.
is greater than 3 and
Hmm.
if n is an odd number, then the number of possible moves is n minus 1. If n is greater than 3 and is an
Hmm.
even number, the possible number of moves is actually n is equal to n.
Yeah.
This is for the night problem, sir, in that
Yeah.
two. But it's only applicable for the diagonals like that.
N is greater than
And
3.
it is an odd
N
number.
is odd, then it's n minus 1, and if n is even, then it's n. Right?
Yes, sir.
Hmm.
N
Uh,
denotes the number of spaces between those two nights.
yeah. Hmm. Okay. So how do we go about trying to prove something like this?
So basically, we could keep 2 nights between some extreme, like there are 8 squares between them, and then we shall find the smallest possible way like that we made it. Or I don't know. Something.
Okay. Uh, hmm.
So, yeah.
Let's start with n is equal to 3. Okay.
No, sir, it's not possible because n is greater than 3, I told you. That's why.
Yeah. So let's start with n is equal to 3 and then we'll go from there.
Yeah.
Then the total
Okay.
solution will be 0 and 1.
Okay. You know what? Fine. Let's start with n is equal to 4. This is
There
n
are
is
4
equal to
possible
4, right?
moves.
It'll take us 4 moves to get there, is what you're saying, right?
Yes, sir.
And one such solution is this, right?
Yes, sir.
Sir, you can also.
So for n is equal to 4, we know this formula works.
Sir,
Okay.
for n equal to 3 also 4 moves are there, no?
Yeah, but according to this formula for n is equal to 3, we need 2 moves, right?
No, sir, but I given if n is greater than 3.
Yeah, no, I'm explaining it to him. I know you've given it for n is greater than 3. I'm just saying why we can't. Like, I know there's a solution for n is equal to 3, but like, we can't do it because it doesn't follow this formula. This formula only works after n is greater than 3.
Sir,
Yeah.
sir, what is n, sir? N.
N is the number of like blocks in the diagonal between the two knights. Like for
Yes, sir.
example, here N is equal to 4.
Yes, sir. Okay, thank you, sir.
Okay. Yeah. So next, let's check N is equal to 5. Okay.
Yes, sir.
When N is equal to 5, I have sorry, 1, 2, 3, 4. Right?
Yes, sir.
Hmm. So N is equal to 5 also it works. How about N is equal to 6?
6 more, sir. We already found it out.
We already checked it for N is equal to 6 as well. But now, how do I extend this for more than 6? Because I don't have
So we
a...
can have any number of squares, sir. Even till if you go till 1 lakh, this formula would work.
Yes, but how do I prove it to you that it works? Like, I agree with you that it works. I know it works. But can you try to like convince them that it works?
We may draw a greater figure like 9 by 9 square and then we may check it out something.
Yeah,
Okay.
for even numbers, we know that for then when n is 2, the number of moves is 2. So every even number is a multiple of 2. So the number of when the number of places increase, it's like doing the same thing again and again. So
Exactly. So when you have it increased by 2 more, right?
Yeah, we'll
You
just
can
repeat
just add,
one
you
more
can
time.
take the previous solution and then you can add this.
This is because 2n is equal to even and 2n minus 1 or 2n plus 1 is equal to odd.
Exactly. So every time we just like the solution increases by 2, we can just add this to it, right?
Yes, sir.
At like the end of the previous solution, right?
Yes, sir.
So I can just like go to my, like if I wanted n is equal to 7, for example. One second. Go here. So this actually increases it by 3, if you'll notice, right?
Sir.
Not 2. Sorry. This increases it by 3.
Yeah. So that's why n is greater than 3. That's why the formula
Hmm.
actually works like that.
So what happens is, if you have I9 minus 9, so n will be 7, and then you can go 1, 2, 3, 4, 5.
6.
No, 1, 1, 2, 3, 4, 5, 6. And n is 7. Yeah. And then for 10 again, you'll go 1, 2, 3, 4, 5, 6. Yeah. So, yeah. So basically, what you end up doing is, I'll just draw it. From here to get to here, we add this move to each of the previous steps, right?
Yes, sir.
Yeah. So what you end up doing is that
We just repeat the same to get to another
yes,
square like that.
exactly. So we're basically adding 2 to every this thing, right?
No, sir, 3, I think.
It's 2 moves, right?
It's 2. The
Sir,
moves is
for
2,
what?
sir, but the n is increasing by 3. I'm saying that.
Yeah, exactly. So here's the thing. Let me quickly see if I can find a. Give me
I
one
care about
second.
the 2n.
Sir,
Yes.
just a quick heads up. We
Yeah.
have
8.
5 to
Yeah. Yeah.
10 minutes.
Yeah.
Yeah.
Um, yeah. This should. This should work. No, this is also 8 cross 8. Hmm. Give me 1 second. Sorry. Okay. Yeah. So I just got like oh. This is a 9 cross 9 chessboard at least. So yeah, basically what we're doing is we're extending it by 3, right?
Yes, sir. The n is extending by 3. The number of moves is extending by 2.
Yes. So Abhinav, are you seeing something that happens in your formula here?
Yes, sir.
You're like if I have n at like some 30 or something, right? Then
Yes,
I would
sir.
have only done 20 moves, right? To get there. Does that make sense? Like here I'll do 1, 2, 3, 4 to get there, and there'll be 5 gaps, right?
Yes, sir.
Versus like 1, 2 to get 2. But then if there's one more set over here, right? There'll
The
be
right
1,
is
2, 3, 4, 5, 6, right?
yes,
6
sir.
moves to get to here. But then 1, 2, 3, 4, 5, 6, 7, 8. There's 8 squares in the middle, and I can get there in 6 moves,
Yeah.
right? So what's actually happening is the number of squares between the knights is growing just slightly faster than the number of moves we're taking, right?
Yeah.
So your formula, like the logic behind it is right, but what do I say? Like the exact formula is not right, because what actually happens is that this thing grows faster. Like for the first few cases, your formula will be right. But if you take n greater than 7, if I'm not wrong, like 6 or 7, like draw it on a piece of paper and see how you can do it, your formula won't work. Like I can find a shorter path than what your formula tells me. So and I like the fact that you said this anyway, but like it was a good attempt. That's why I wanted to like discuss this for the last 15 minutes. I'm gonna add this as one of the assignment questions as well. I want you guys to like give me a formula for what the shortest path will be for when there's n squares between the two knights. Okay.
So actually for 2, if n is equal to 2, the number of ways, the moves is also like 2, sir. No,
Yes.
they're
But
different.
like I want it for like any number of n.
Oh.
Okay.
Then, yeah, what you
Think
told was
about it.
correct. The
Think about
logic
it.
is correct, but
Yeah.
yeah.
Like I've kind of given you a hint, but yeah. Okay.
Yes, sir. It has to be
So
equivalent.
I think like with that I have everything I've prepared for is I've kind of covered everything I wanted to cover. Does anyone have any doubts?
No, sir.
Okay,
Okay.
so if there are any doubts, we can take the doubts after we officially formally close
Okay.
the session.
Sure.
So we'll go to the vote of thanks.
Okay, so we had Sudhya sir with us for 2 sessions. In those 2 sessions, we covered a lot of things. We started off with exploring the Knight's tour, and then we went to the Queen's tour. We looked at 8 queens, and then a brief extension to n queens. And lastly, we looked at the Rook's tour, and we explored Abhinav's formula in the end a little bit, right? So you can see how vast the content we've covered in these 2 sessions are. Like the pace was actually wonderful. Thank you so much, sir. And also, I feel like the interesting part about the session was that although we did do a lot of combinatorics, it was in a very interesting way because it was with the chessboard and it was sort of in the form of a game. So it was a really nice way to do it. And one interesting thing that all the volunteers and I noticed about the session is usually sessions are all raise your hand and be order and all that. But these sessions are pretty free, and I'm pretty sure all the students had a nice time just talking whenever they wanted in an ordered way. But it's still nice to have that discussion and just talk and have a nice conversation with Hidaya sir and everyone else. So once again, thank you so much, sir, for this session and for Ram Foundation for organizing this session. Thank you.
All
Okay,
right.
now we can take questions.
Yeah, we're formally closing the session. Those who want to leave can leave for their break, and those who have questions can stay back and we can have the questions. Okay, Abhinav has a question.
Yes, sir, but I still don't understand how will, if n is greater than 7, how will not my formula work? I still don't understand it.
Okay, let me just draw a chessboard for you real quick.